From the ABC 27 Storm Track Center, it's time to go beyond the forecast.
Well, good evening and welcome to our fifth installment of Beyond the Forecast. I'm meteorologist Ryan Coyle.
And I'm meteorologist Eric Finkenbinder. Now, these seasonal half-hour shows gives our weather team the chance to talk about our local weather and climate separate from the daily newscast. Now, so far, we've talked about tropical systems, the science of climate change, and severe weather in the mid-state. Tonight's show will focus more on the climate of south central Pennsylvania, more specifically, the climates.
Yeah, the climate data that we use in our weathercast is recorded at the Harrisburg International Airport. But we live in a region filled with mountains, valleys, large cities, small towns, and plenty of agriculture in between. All of these have an effect on our climate, and that's what we're focusing on this evening, to locate the regions that have slightly different climates.
And in order to find these microclimates, we need to first look at the structure of the land. Our friends at the Department of Conservation and Natural Resources were happy to show us the geographical regions of south central PA. Gary Flieger is the chief of the Stratigraphic Studies section of the Geological Mapping Division of the Geological Survey. In order to find the geological regions of south central Pennsylvania, we first need to understand how it was formed.
Several times there have been mountain building events to the east and southeast of Pennsylvania, and when those mountains were raised, they started to erode, and the sediment was transported into what's now south central Pennsylvania and deposited as sediment. There were many thousands of feet of sediment were deposited, and as the sediment was buried, it was turned into rock. During the last mountain building episode, North America and Africa collided, and it folded the rocks from the pressure of the two colliding continents, just similar to when a rug is crumpled when you push on it. Here's an example of a folded rock.
There are several locations where you can view examples of the folding rock, including this small fold along Route 322 just as you enter the Lewistown Narrows. Erosion of this sediment over 150 to 200 million years resulted in two broad geological regions.
There are two main distinct regions. One would be the Ridge and Valley, which is an area of long linear ridges and intervening valleys. And the other part of south central Pennsylvania would be the Piedmont, which is separated into two areas based on their origin.
When you add a variety of weather conditions to these two provinces, we find four specific areas, each with its own climate. The narrow ridges and valleys of Perry, Mifflin, Juniata, and northern Dauphin counties, the Great Valley, South Mountain, and the low-lying Piedmont of Lancaster and York counties. We learn a little about each section, starting with the Ridge and Valley.
It's an arcuate region of long linear ridges, narrow ridges, and intervening valleys. The ridges are made up of hard rocks that are resistant to erosion, such as sandstone, and the intervening valleys are soft rocks, which are not resistant to erosion, and that's why they're the low areas. They're mostly shale and limestone type rocks. The Great Valley is a very wide, long valley that goes from up in New York all the way down to northern Georgia or Alabama. It's an area that's fairly low relief because since it's a valley, it's obviously underlain by rocks that are easily eroded. South Mountain is the northern terminus of the Blue Ridge that goes all the way down to northern Georgia. It's fairly low and broad up in this area, and actually gets much wider down in the Great Smoky Mountain area. The Piedmont in south central Pennsylvania is divided into two areas. The southern part is a core of former mountains, and that area is largely in York and Lancaster counties. Those mountains have since been eroded, and we just have some low rolling hills remaining. Just to the north or northwest of that is an area that passes through Gettysburg, Adams County, and northern York, southern Dauphin. And that is an area that's a rift basin that was formed when the continents of Africa and North America separated. The mountains on either side of that were eroding and sediment was washing into that basin, which has been filled in now. So the topography of both sections is very similar, and then you have low rolling hills.
Now that we identified the different geological regions, it's up to the ABC 27 Storm Track Center team to show you how the climate can vary in each 4 of these locations.
And that's exactly what we plan to show you coming up next on Beyond the Forecast.
Yeah, stick around to see how the weather interacts with the land and what type of climate you experience in your backyard.
Plus, Dan is at the beach. Well, not exactly, but he gets all sciencey as he explains how the Atlantic Ocean plays a big role in our climate. Stay with us.
Welcome back to Beyond the Forecast. From above, the 10-county region that makes up our part of south central Pennsylvania, it looks rather straightforward. But if you look at it from another angle, you see just how different the terrain is. We saw that earlier in the show. We learned earlier, central PA can be broken down into 4 distinct geological regions. But what does that mean for our weather? Well, we begin our search at Wagoner's Gap on the Cumberland and Perry County border. At about 1,600 feet in elevation, we get a pretty clear view looking off to the south and the north. And in this case, if we look off to the north, you could see Perry County, but you can also see into parts of Juniata and Mifflin County, the Ridge and Valley region. This area is known to experience large fluctuations in precipitation type during the winter season. Rain in the valleys, snow in the ridges. But in general, this 3-county region, along with Upper Dauphin County, tends to see the least amount of annual rainfall when compared to counties to the south. Now take a look at this radar loop from earlier this year. You see a line of storms to the left on a summer afternoon, yet when they cross the Allegheny Mountains of western Pennsylvania, the elevation breaks up the storms. By the time they get to Mifflin, Juniata, and Perry counties, they're just a shadow of what they once were. And there is data to back this up. These monthly precipitation maps show the lack of moisture in the Ridge and Valley region. Not just one month in particular, but in general. Continuing from our perch up here on Wagoner's Gap Road, all you have to do is now look to the south, and you look out over Cumberland County, what geologists call the Great Valley. This is where the bulk of our population lives.
Great Valley, I think, was one of the areas that was probably settled the earliest, and it's an area that is fairly low relief. It's not a barrier to transportation, so transportation was fairly easy for the early settlers, so they first settled here. So the towns are older in this area. For example, Interstate 81 follows the Great Valley all the way down through Virginia because it's a great transportation corridor.
The Great Valley is known to be cloudy at times. Sometimes we'll get a cool easterly wind to kind of ride in with clouds, lock up against the mountains that we're standing on right now, and keep the Great Valley cloudy almost all day long. Now take a look at this Toyota WeatherNet time-lapse video from Annville in Lebanon County. It shows the clouds in action. The Great Valley can also experience a heat island effect. Look at this map that shows the green forested land versus the yellow cleared and pink developed land. The lack of widespread trees and industry in this area can lead to warmer temperatures in the valley. Compare that to the forested areas of Perry County to the north. Our cooler temperature readings on a summer morning are not found in a Mechanicsburg, for example, but instead in a New Bloomfield, just about a dozen miles to the north. So that's 2 of the 4 regions that affect our weather pattern here in south central Pennsylvania. Coming up after the break, we head across the valley to South Mountain and talk snow. Welcome back to Beyond the Forecast. We've switched sides on you. Now we're in the southern part of Cumberland County near Hunter's Run, and we're talking about what you see behind me. We're right on the fringes of it now, South Mountain. Now just like any elevated area, they can get snow in the higher elevations when the lower elevations in the valleys get rain. Now in fact, South Mountain seems to get the earliest snow in the fall, and most often the latest snow comes spring. The area is also known to get some nasty ice storms, but the rain and snow can lead to more annual precipitation up on the mountain. With storms coming up out of the south, the extra lift of the mountains can create more precipitation than for areas in lower elevations nearby. The blue on this map shows annual precipitation around 50 inches. In the nearby valley, only 40 inches. Now, on the southeastern side of South Mountain lies the 4th geological region of central Pennsylvania. Through the magic of television, let's take you now to the Piedmont. Welcome to Paradise. Paradise Township, that is, here in York County. It's what geologists refer to as the Piedmont region. We simply refer to it as the rolling hills part of south central Pennsylvania. And it is an area that is heavily farmed, and for good reason. In the summer months, it's a region that can get rain when others don't. Watch this radar loop. As storms push through the mountains, they lose their steam. But when they hit the Piedmont, they fire right back up and drop a lot of rain. Part of the reason is because of the Piedmont's proximity to the Chesapeake Bay. This creates an atmospheric river of moisture that helps promote the heavy downpours. Areas farther north and west are too far removed from this influence. This river of muggy air can also create problems in the Piedmont. The region typically sees more tornadoes annually than the rest of central PA. The muggy air adds an extra ingredient to severe thunderstorms that can occasionally spawn a tornado. Meteorologists have even dubbed the Piedmont as a mini tornado alley in Pennsylvania.
It's nothing like the tornado alley in the plains, of course, where there's hundreds of tornadoes a year. But in a state as large as Pennsylvania, there's a little higher likelihood down here in our neck of the woods than there is, say, in State College.
You know, it's interesting. I was out there shooting it with the photographer, and just driving 10, 15, 20 miles, you really do go throughout a variety of geological formations. We almost take it for granted. You know, people that live in the Great Valley, first of all, may not even know it's the Great Valley, but they live there, they see the hills off in the distance, they just think that's how it is. But we live in a really varied area.
And I think it's pretty awesome to actually hear how it was formed and how awesome it would be to take a time lapse of the last 150 million years to actually see how south central Pennsylvania is now the way it is.
Yeah.
So it's pretty awesome stuff. Hey, now looking back on our summer, I'm sure many of us traveled east for a relaxing vacation at the beach, or maybe went a few hours northwest for a fishing trip on Lake Erie.
Yeah, these large bodies of water can bring some big storms to the mid-state and affect the overall climate.
It's time for meteorologist Dan Tomaso to get sciencey to explain.
A fundamental part of understanding meteorology is knowing how weather systems are affected by land and water. In general, low-pressure systems that originate and move over land bring far less moisture than storms that have their roots from bodies of water. Classic examples are light snow events called clipper systems that move across southern Canada and the northern United States. In comparison, coastal low snowstorms bring much more wintry weather and our heaviest snowstorms here in Pennsylvania. The contrast between land and water is also very important for the process of cyclogenesis, or the process of storm generation, as you see here. In the wintertime, air masses over the land and on the east coast are cooler than the nearby air masses over water. This temperature contrast creates a baroclinic zone, an area that is favorable for storm development, as seen here. Now, such baroclinic zones enhance the development of large and destructive winter storms too, including the blizzard of 1993, which formed over warm Gulf of Mexico waters as cold air plunged south. Now, other localized big snowstorms have been generated thanks to smaller bodies of water, the Great Lakes. Now, cold air blows over the warmer lake waters, and this drives the process of convection, creating hard-hitting snow-making clouds. The areas affected by large lake effect snowfall events are really determined by the direction of wind over the Great Lakes. But some famous places for lake effect snow include the Tug Hill Plateau of New York between Watertown and Syracuse, seen here in blue, and also northwestern Pennsylvania is a very near and dear place that sees a lot of snow. Very rarely, though, do these lake effect snowstorms extend far from northwestern Pennsylvania, but sometimes our counties of Mifflin, Juniata, Perry, and Cumberland, even sometimes Franklin, can see a few flakes from long-lived snowstorm bands. For Beyond the Forecast, I'm meteorologist Dan Tomaso.
You know, I always tell people I broke the mold a little bit. I'm a Syracuse grad. You guys all went to Penn State,
right.
But Syracuse got a lot of lake effect snow, but Penn State did as well.
Yeah, we would see a few inches of lake effect snow from time to time. Around here, though, our big plow-busting snows comes from the nor'easters and a lot of those storms coming up from the Atlantic Ocean.
But it's interesting. Both of them have connections to the big bodies of water, like Great Lakes or Atlantic Ocean, just like Dan said. Well, stay with us. We have much more coming up after the break.
Meteorologist Brett Thakra looks between the lines of latitude. You're watching Beyond the Forecast, the climate of Central PA on ABC 27. Well, welcome back. Lines of latitude extend from the equator to the North Pole, and Pennsylvania is located in the mid-latitudes, which is a perfect location if you enjoy cold winters or blazing hot summers.
Yeah, a little bit of both. It's a region that experiences all 4 seasons, actually. Meteorologist Brett Thakara talks more about our location at 40 degrees north latitude.
Latitude is an important factor when discussing climate. Certainly that may seem like common sense. The farther north you go, the polar regions are capped with ice. The tropics have a lot of warm weather. But even locally, latitude is so important, and that's why I'm standing here along the Pennsylvania Turnpike. It is a landmark we use in our forecast to differentiate between our northern tier counties and our southern tier counties, which have a vastly different climate. More on that in just a little bit. But in terms of why Pennsylvania has such a unique climate, for that, we turn to some thoughts from senior lecturer at Penn State, Fred Gadomski.
Pennsylvania is at the crossroads of the jet stream, and it is also a place that has nearby large bodies of water. It's a place with complicated terrain effects. All those things together make Pennsylvania one of the ultimate weather playgrounds for a meteorologist, and also it makes it very interesting if you're just a weather lover and a weather watcher.
Thanks as always to Fred Gadomski for that great insight on climate factors that affect Pennsylvania. And we'll get back to the Turnpike in just a moment. But let's take a broader view now of why the mid-latitudes are so important and why everybody's latitude has an impact on climate. At the mid-latitudes, much like Eric Finkenbinder and I on a daily basis, there's a fight going on. And this fight is between warm air and cold air in the atmosphere. You know, in the northern latitudes near the ice caps and the poles, the cold air, that's constantly wanting to move to the south. Warm air near the equator is constantly wanting to move to the north. And in between, right where we sit, that's called the mid-latitudes. And so you get this constant battle between warm and cold air, and that's why we have active weather patterns. Even on a smaller scale, you know, the farther north you live, the more of a winter type influence you get, more of that polar influence you get. The farther south you live here, and it's all based on latitude, the more of a tropical influence you get. We are right in between, right along that 40th parallel here in our viewing area, so we get polar influences, we get tropical influences here in Pennsylvania. But even on the smallest of scales, latitude plays an important role, and that includes here for fall foliage. You know, we're heading into the fall season, and you can see that we've got the fall foliage peaking across northern Pennsylvania much earlier than it does for most of our viewing area, which is in mid to late October. And that's just based on where you sit here during your line of, or on your line of latitude. Pennsylvania, and the February high temperature chart showing you anywhere from 35 to 40 degrees for an average high across the northern tier counties, but the southern tier counties are about 5 degrees warmer than that. Areas in red have an average high in February of 40 to 45 degrees, and if you look at that line, that kind of follows the Turnpike, and that's why we started this piece at the Turnpike, because it's such a great indicator of different weather patterns here, almost bisecting our viewing area. So once again, when you look at that here, at the close-up view, you see how closely that average temperature map follows the Turnpike. So there's different climates across our northern tier counties and our southern tier counties, all based on latitude. For Beyond the Forecast, I'm meteorologist Brett Thakara.
Thanks, Brett. Stay with us. Coming up after the break, we talk about our next Beyond the Forecast as we gear up for winter. We hope this program was able to show you what determines the climate of south central Pennsylvania. When you sum it all up, it comes down to 3 factors: topography, our location and latitude, and our proximity to the Atlantic Ocean and Lake Erie.
Yeah, so even though we use just one location to determine the official high and low temperature of each day, it may be warmer or cooler depending upon where you live. And I'm sure we'll see a myriad of snow amounts for the mid-state this winter because of those reasons.
And that brings us to our next show. In December, we'll bring you another Beyond the Forecast, and we go behind the scenes in the ABC 27 Storm Track Center.
We'll show you how we forecast and give you a tour of the inner workings of the Weather Center. Tune in for Beyond the Forecast Behind the Scenes. That's December 10th at 7:30 right here on ABC 27.
And you can catch a rebroadcast of tonight's program this Thursday and Friday, September 19th and 20th at 8 p.m. on our Storm Track Center 24/7 channel.
Well, that's all for this edition of Beyond the Forecast. Thanks for watching. Have a great night.
Have a good night.